In this example, we're going to find the area of the region enclosed by the following curves. Our first curve is y is equal to x plus 2, and the second curve is y is equal to minus x squared plus 4. The first thing that we want to do is to find the points where the two curves intersect. We're going to do this by setting the two curves equal to each other. So we have x plus 2 is equal to minus x squared plus 4, and we need to solve for x. Let's pull everything over to the left, and that gives us x squared plus x plus 2 minus 4 is equal to 0. So we have x squared plus x minus 2 is equal to 0. We can factor this as x plus 2 and x minus 1. And this gives us that x is equal to minus 2 and x is equal to 1. Now what we need to do is find the y value of these points of intersection. To do this, we are going to look at the two curves that were given and use the easier one. That's going to be this one, y is equal to x plus 2. So let's write that up here. Y is equal to x plus 2. When we have x is equal to minus 2, y then is equal to 0, and we get the point minus 2, 0. And then when x is equal to 1, y is equal to 3, and we get the point 1, 3. Let's go ahead and highlight these because we are going to need to plot those in our next step. Our second step is to graph the region. We're going to begin by plotting the two intersection points that we just found. The first point is at minus 2, 0, so we'll put that right there. And then the next point is 1, 3, and we'll put that point right here. I find that I like to wait to label these 2 points until I go ahead and get the graphs drawn. That's what we're going to do now. We are going to graph our two curves. Let me put them up here so we remember what they are. We have y is equal to x plus 2, and we have y is equal to minus x squared plus 4. Let's graph the line first. That is just going to go between our 2 points of intersection. And then our second curve right here is a parabola that opens downward, and the vertex is 0, 4. Our vertex is right here, and we know that it's going to go through our 2 intersection points, so we can just graph it like this. There we go. The area that we're going to find is this area in here. Let's go ahead and let's put some labels on our graph. We'll label our intersection points. This point down here is minus 2, 0, and this point up here is the point 1, 3. Our line is the graph y is equal to x plus 2, and our parabola is y is equal to minus x squared plus 4. It really helps to label the graphs when we go to set up our integral. The next thing that we're going to do is choose the formula for our area. We need to choose the formula based on if we want to integrate with respect to x or respect to y. If we integrate with respect to x, we want one curve on the top and one curve on the bottom. If we draw some straight lines, you can see from our graph that we do have one curve on the top and one curve on the bottom. Now let's see if we can integrate with respect to y. We need to see if we have one curve on the right and one curve on the left. If we draw a horizontal line, you can see that we have the same curve on the right that we do on the left. So we do not want to integrate with respect to y. So we are going to choose the formula. Our area is the integral from a to b, the curve on the top, yt, minus the curve on the bottom, y sub b, dx. Our curve on the top is our parabola, and our curve on the bottom is our straight line. Let's now set up and evaluate our integral. Our area is the integral from x is equal to -2 to x is equal to 1. Our curve on the top, which is minus x squared plus 4, minus our curve on the bottom, which is x plus 2. And then we have our dx. Let's now simplify our integral. -2 to 1. We have minus x squared plus 4. And then we're going to be subtracting both x and 2. I think that's the biggest mistake I see students make, is to not carry that minus sign through to both terms. This gives us a minus x minus 2 dx. And this gives us the integral from -2 to 1 of minus x squared minus x plus 2 dx. Now we can go ahead and integrate this. Our first term is minus x cubed over 3, and then we have a minus x squared over 2, and then our last term is plus 2x, and we're evaluating this from -2 to 1. Now let's plug in that x is equal to 1. This gives us minus 1/3 minus 1/2 plus 2. And then we're going to subtract off minus a minus 2 cubed over 3. We have a lot of negatives there. Minus a minus 2 squared over 2 plus 2 times minus 2. Now let's go ahead and let's simplify this. This is minus 1/3 minus 1/2 plus 2 minus, we have minus 2 cubed, which is minus 8, multiplied by a minus 1. So this is 8 over 3. And then we have a minus 4 over 2, and then a minus 4. This gives us minus 1/3 minus 1/2 plus 2 minus 8/3 plus 4 over 2, which is 2, and then plus 4. This is 2 plus 2 plus 4. That gives us an 8. And then we have a minus 1/3 and a minus 8/3. That's minus 9/3, which is minus 3. And then we have minus 1/2. So this is 5 minus 1/2. And that gives us a value of 9/2. So the area between these two curves is equal to 9/2 or 4.5.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.